Welcome to Jom Study YouTube channel. Today, we will discuss a topic related to equilibrium on essential concept in chemistry that help us understand how reactions behave under different conditions. Equilibrium occurs when the rate of the forward and reverse reactions are equal, leading to a stable concentrations of reactant and products. We will explore the principle of chemical equilibrium, the factors that affect it, and how to apply the Chatelier principle in various scenarios. Without further ado, let's get started. Equilibrium refers to a state in a chemical reaction where the rates of a forward and reverse reactions are equal, meaning that the concentration of reactants and products remain constant over time. It doesn't mean that the reactions have stopped. Instead, they continue to occur, but there is no net change in the amount of substance involved. Example, think of it like a balanced scale where both sides are equal. Dynamic equilibrium is when a chemical reaction is happening in both directions at the same speed, so the amount of substances stay the same. Example, Haber process. In the Haber process, nitrogen and hydrogen gases react to make ammonia. Nitrogen and hydrogen combine to form ammonia. Ammonia can also break down back into nitrogen and hydrogen. At dynamic equilibrium, the rate of making ammonia equals the rate of breaking it back down. So, the amount of all three gases stay constant, but the reactions keep going. Le Chatelier principle states that if a dynamic equilibrium is disturbed by changing the conditions, the system will adjust to counteract the change and restore a new equilibrium. And these can involve changes in concentration, pressure, or temperature. For example, if the concentration of reactants is increased, the system will shift toward the products to reduce their concentration. Le Chatelier principle helps us understand how a system at equilibrium reacts to change in condition. Key factors that can affect equilibrium include concentration, temperature, and pressure. For general reactions, Ma plus Mb equals equilibrium Pc plus Qd. Where delta H is negative, indicating an exothermic reactions. Factors 1 is increasing concentration. If we add more of either reactant A or B, the system will shift to produce more product C and D. And factors 2 is increasing temperature. Since the reaction releases heat, rising the temperature will favor the reactants, resulting in fewer products. In contrast, for an endothermic reaction, increasing the temperature would lead to more products being formed. Factors 3 is pressure changes. This mainly affect gas-phase reaction, for example, in the Haber process for producing ammonia. And increasing pressure will shift the equilibrium towards the side with fewer gas molecule, which in this case is the product side, which is referred to ammonia. Overall, a catalyst can also be used to speed up the reactions without affecting the position of equilibrium. Tips for answering examination questions. For below reaction, use the Chatelier principle to decide what will be the effect on the position of equilibrium as a result of the changed state. And we have Q and O in the form of gas plus O2 also in the form of gas. And we have the products 2 and O2 in the form of gas. And the situation is exothermic, which is delta less than 0. And you have to decide what will be the effect on the position of equilibrium when there is increase in terms of the temperature and increase in terms of the pressure. So reactions type is exothermic and mole of gas is a reactant is 3 mole, which is 2NO plus 1 O2 become 3 moles. And the product you have 2 moles, which is 2 NO2. In terms of the effect of increasing temperature, understanding temperature change in an exothermic reaction, heat is released as a product. So you can think of it as 2NO in a form of gas plus O2, and there is a product which is 2NO2 in a form of gas plus heat. Based on the Chatelier principle, when the temperature increases, the system will try to counteract this change. In terms of the directions of shift, to counter the increase in temperature, the system will shift in the direction that absorb heat, which is endothermic reaction. And this will reverse the reaction. As a result, the equilibrium shift to the left toward reactant, which is NO and O2. In terms of the effect of increasing pressure, understanding pressure changes affect the site of the reaction with more or fewer gas molecule. Moles of gas reactant is 3 mole and the product is 2 mole. And the Chatelier principle, when pressure is increased, the system will shift to reduce the pressure. And the direction of shift, the system will favor the site with fewer gas molecule to decrease the overall pressure. And as a result, the equilibrium shift to the right towards product. Summary of the effect, when there is increase in temperature, it will shift to the left, which is favor to reactant. But when there is increase in pressure, it will shift to the right, which is favor to the product. Let's look into the equilibrium constant. The equilibrium constant, which is so-called K, is a number that expresses the ratio of the concentration of product to the concentration of reactant in a chemical at equilibrium. A relationship that relates the concentration of reactant and products at equilibrium is referred as law of mass, actions, or equilibrium law. This relationship is constant, known as equilibrium constant, K. MA plus NB with the sign of equilibrium become PC plus QD, where A, B, C, D are the reacting species involved and M and PQ are the stoichiometric coefficient in the balance equation. At equilibrium, the equilibrium law can be expressed as Kc equal the concentration of C raised to the power of P times the concentration of D raised to the power of Q divided by the concentration of A raised to the power of M times the concentration of B raised to the power of N. The square bracket signify amount concentration. The constant K is the equilibrium constant. For homogeneous chemical equilibrium, when the concentration of reactant and products are expressed in amount concentration, the equilibrium constant K is written as Kc. But if the reaction is homogeneous, gas phase reaction, then the equilibrium expression can be written in terms of partial pressure. Kp equal the pressure of P is raised to the power of Q I repeat, Kp equals the pressure of P is raised to the power of P times the pressure of Q is raised to the power of Q divided by the pressure of A raised to the power of A times the power of B raised to the power of B. The value of equilibrium constants only vary with temperature. Expressions for equilibrium constant of a reaction is written in the form of ratio, which numerator consists of amount concentration or partial pressure terms for the product, each raised to the power equal to its stoichiometric coefficient. In balance, chemical equation and denominator consists of amount concentration or partial pressure terms for reactant, each raised to power equal to stoichiometric coefficient. In balance, chemical equation. However, for heterogeneous reaction, the concentration term of pure solid and pure liquids are not included in the expression of equilibrium constant. When we are looking at concentration of liquid and solids, we are really looking at density divided by molar mass, where the formula is density divided by molar mass. You get the value is mole centimeter cube. Since the density of any given solid or liquid is constant and changes very little with temperature, we can say it is constant. Therefore, for heterogeneous reaction, the concentration of pure solid and liquid can be neglected. Tips for answering examination questions. Write equilibrium expression in terms of Kc for each of following reaction. Question A, we have nickel solid react with 4 mole of carbon monoxide gas to reach equilibrium with nickel tetracarbon carbon gas. So the equilibrium constant, which is Kc, which is the result or the solutions for the question number A, is equal to the concentration of nickel tetracarbon divided by the concentration of carbon monoxide raised to the 4 power. So in this case, please note that nickel is a solid, and in equilibrium expression, The concentration of pure solid and pure liquid are not included. So only the concentration of gases and aqueous solutions are considered. For the questions B, we have a calcium bicarbonate in aqueous solution is in equilibrium with solid calcium carbonate, liquid water, and carbon dioxide in a form of gases. This question is actually describe the equilibrium reactions involving calcium bicarbonate dissolved into its product. And the equilibrium constant Kc is equal to the concentration of carbon dioxide divided by the concentration of calcium bicarbonate raised to the 4 power. Why it is 4 power here? Because it's come from the stoichiometry of the balance equation. For every mole of calcium bicarbonate that this associates, it produces 1 mole of carbon dioxide. And since the formula for calcium bicarbonate is CaHCO3 in bracket 2, there are 2 bicarbonate ions for each calcium ion. Thus, the concentration of calcium bicarbonate is raised to the 4 power because it includes both the calcium and the 2 bicarbonate ions. And in these expressions, H2O is omitted from the expressions because H2O is a water. Water is a pure liquid in these reactions. And according to the rules for writing equilibrium expressions, the concentration of pure solids and liquids are not included in the expression. So only the concentration of gases and aqueous solutions are included. Without being said, that concludes today's session. And I look forward to seeing you at the next session. Please subscribe to Joom's Chatelier YouTube channel. And don't forget to turn on your notifications so you don't miss any update. Wishing you all the best in your studies and upcoming examination. And thank you for your support and cooperation.